G'day everybody, it's Rob from Fireflight Photo. Let's take a look at virus growth and explain it in tyFlow. So the bent flat box hits and that initiates this virus growth, and that's all it needs to do is hit and touch, and then the virus growth just keeps going and going and going over time until it eventually covers the whole surface of the cylinder. How does this work? Alright, so we start here in event 1 where we birth XXX particles, right? I think I did about 6,000. And then we place them on the faces of the object. In this example, we're doing a cylinder. So at this point, we've birthed and positioned them, and our viewport looks something like that. So now we need to kind of initiate a growth. So for that, we'll get a little box and we'll just animate it and run it across the bottom of this cylinder to start the virus growth. So that means we're going to take this surface test, and once some particles have been hit by that, we're going to send them out to this event 2. In which case, we're going to make the particles part of a group. We can use one, as long as we use the same one, it doesn't matter. And why are we doing that? The reason we're doing that is the nature of this property test with neighbors is you would get an instantaneous transition of particles, not a gradual rise, right? We're going to go a gradual rise, gradual rise, gradual rise. If we didn't kind of try and do a time test in between. So why do we need particle groups? Well, if we send those initial first particles out and put them into a group, and then we make sure our property test is only happening on that group, right? That means we'll get a gradual growth pattern. Then we have a few more because of the way that we group them, and they get grown and this circles around like this. But the main reason here is if we didn't try to separate this into steps, and we're using the power of grouping to do that, then all of the particles would more or less turn at once. So the kind of idea behind this sequence of events is by placing them in groups and then having a time test that we can adjust, we can control the rate of growth of the virus. So, and this is kind of the basic steps that I just talked about, right? And now that we've kind of seen the theory behind this virus growth and how it works, let's do the tutorial inside of Max. Okay, so let's take a look at this in real life. So we got this cylinder and we got this weird shaped object. And why did I make it a weird shaped box? Well, I made it a weird shaped box so I had a more interesting growth pattern with a little bit of variation. So I just took a box and flattened it. But compared to the theory we just did, so we birth 6,000 particles at frame 1, and we place them on the face of this cylinder, and that's the only settings in these 2 boxes. Then we do a surface test, and we test against our bent box, and our bent box is animated to cut through and touch some of the particles. Because we did a surface test at whatever distance and variation, so that's just the distance and some variation, again to add more variety to our virus growth, so it doesn't just go linearly up. That was a word. So we send them over here, and we can see that by the change in color, and they become blue, and we make them part of group 1. And the reason we're going to do that is because we're going to do the property test on group 1, which is only this small group of particles, the blue ones, right? if we did them on all the yellow ones, we would get an instant virus growth. So we need this growth to happen slowly over time. So by turning these into group 1, the blue ones, now when we do the property test, and this is greater than 3 and absolute radius 6 is my settings for you, that's all that's changed, except this is also being performed on group 1. So we're only doing a property test on the blue particles, and then we're sending them in here where they become pink. So we can see a few pink along here on the edges, right? And this is all controlled by what we set here as far as the distance, right? And we're delaying with some variation before they come over here and become part of group 1 again, like where they get left alone, and then we essentially start the whole process again. So frame by frame we see it in action. Some blue particles come over here, become part of group 1. They then get tested, so we can do a neighbors test, and we're just slowly get more pink added all around the edge. We delay the whole procedure from happening again, and then based on whatever the delay is, whatever we got set in the original surface test and the distance we set here is going to be how fast this virus grows. So for example, if I said radius of 1, you can see we got a much larger surface of virus growth, and you can see there's more pink particles per frame. We originally had 0.6 here. You can see the difference. The growth is much slower and there's fewer pink particles, right? And when we do say 1.2, probably finished already, you can see there's a lot more bluer particles at that same time step, and there's a lot more pink ones that'll get reevaluated next time round. So that's how that virus growth happens. It just happens steadily, and on this property test here, you know, that's really what makes this happen over and over. Okay, so let's understand this growth pattern. I'm going to turn off the yellow particles so it's easier to see. Remember, the property test is only being tested on group 1 particles, which are created over here. So first we create the group 1 particles, then when we go back around next frame, then the neighbor test is performed on those blue particles. So because we're only performing neighbor test on the blue particles here, right, then the test is being done from the yellow, is being done from the yellow to the blue, right? What is their relationship distance wise? So if I do something like 0.8, it advanced the growth, but you can see we have more pink particles, so we temporarily have more pink particles in here, and then we kind of delay their sending over to here, so we actually control this growth over time with this time event and also the rate at which we're growing the particles. But you can see by increasing this test distance, we're going to get more per frame. So if I do 1, you can see we get a lot more. So the growth is going to happen faster per frame. You know, so we can control the growth in a way by adjusting this radius, and also what we do here with the time test. So when we look at this thing in real life, you can see first we grow a few particles with the collision of this oddly shaped box. That just creates variety, because you can see pink ones are spread all amongst, so we've created some real randomness to this growth pattern. And then as we grow over time, you can see we just keep closing. All of the bottom now is blue. It's all been put into this final event here, where you would, if you're going to do a time measure or something to make this look like some sort of growing mesh, then this would be the event where you would do that. And for now we can simulate that in a way by putting the shape operator on, right? and then showing this as a shape instead. Geometry, right? And you can see now in a way we're simulating the growth. We could get a much smoother and more realistic kind of geometrical kind of pattern if we use tyMeasure. So we just let the time slider go, and eventually the growth just reaches the top and we complete the flow. So even though it's a simple flow diagram in a way, you got to kind of think about it to figure out how it really works. So that's the way that you make a virus growth using tyFlow in 3ds Max. And there's nothing special. Going over the flow, we don't need to build it in front of you. Going over the flow, we birth 6,000 particles on the cylinder. We place them on the surfaces, right? When we look here, we select the cylinder and they're placed on the faces. We do a surface test, and it's against this moving box, and if the box hits, we set the distance. That starts the initial growth. That's all that does. When this hits, that starts the initial growth, those first initial particles. We make them group 1. By doing that, we limit the explosion of the virus growth, because on this one we're going to make sure it's only testing against group 1. And once the test is performed and we got some particles, we send them over here and create a time delay. So again, we don't get an explosion of virus growth. We can control it a little bit. If we made this 6, we get slower virus growth, right? If we make this 1, we get faster virus growth. So this is just a delaying tactic. We'll put it back at about 5 and then we'll see it. And then because of this cycle of shifting the particles around like this, delaying them, and only testing against group 1 particles, that's what limits the virus from instantaneously taking over the whole object in one frame. It's that combination of placing them in a group and then doing a time test to delay the growth. So, you know, you can see there's nothing special to anything in this flow diagram. We really shouldn't need to build it step by step. And if you want an idea of size, you know, this cylinder here is just 2.7 radius and 20 centimeters tall. And then you can just see the settings here for the distance test on the surface, and you can see the radius test and settings here on the property test operator. And the time test obviously is pretty simple. And that's it. Remember that this is in group 1, so it only tests for group 1 growth, and when we put the particles over here, then group 1. I hope that helps you make some sort of awesome virus growth animation. And remember, the next step to this procedure would be actually use tyMeasure to turn this into an animated mesh object. Have fun. Well, I just play the animation in real time, and what I'll say is this: for those that want a walkthrough, I'll create it and tag it on the end, and we'll create the whole thing from scratch. For those that are comfortable with the tutorial at where it's at, have a great day, and we enjoyed your company. Take it easy. For those that stayed, welcome. So we've got a cylinder here, and I'm not going to create them, right? It, like I said, it's 2.6, almost 2.7 in diameter and 19.5 tall. And the box here just has the bend on it, right? And it's just a 0.2 thick, 5 1/8. and just bent so that the contact is more random on the surface. So now we're going to burst some particles, and we can modify this later, but we'll do say 3000 for now on frame 0. Then we're going to position them on the faces. So tab, position, object. We're going to pick this, and that places them on the face. And we'll just show them as large dots for now, and we'll make them yellow-ish. And there we go. So now we can adjust the quantity of birth particles. So now we need to do a surface test, right? So we hit tab and do surface test. And the surface that we're testing against is this box. And we come down here and we adjust its setting. So we'll send them out to a new event, which will give a new color, and keeping in what we had in the previous thing, we'll do it a bluish color. So without doing anything else right now, we can see what's going to happen, and we can see it's way too much, way too soon, right? Alright, that's not how we want to start. So let's try something like 0.75, which is what we had in the original video we played, and let's see how that looks. And now you can see that all that's happened is we've created some blue particles that are not a part of our original particles, and these are what we're going to use for the virus growth. So what we want to do with these particles, hit the tab key and start to type group. And what we're going to do now is make them part of group 1. All that means is when you have particle groups, operators must be in the same group to have any effect. Operators in group 1 can only interact with particles in group 1 and vice versa. So now we come over here and we're going to do our property test. And we do our property test, put it down here and just switch the output side. So switch the output side. Now we're going to do neighbors, right? So neighbor count. And we're going to do I should have had this on 0. And we're going to make this part of group 1. So it's only going to test against those blue particles, right? And then we're going to come back up here and we're going to adjust our test. And I think, you can play around, but we had 0.6 in the other, and that was just, I played around. We can still play around with that. And now we're going to send them out down here to a new event, where all we're going to do is try and control the time. So we want to delay this growth from happening too fast, right? Now you can see they instantly turn green, and that's because we haven't finished setting the settings here yet. We set the absolute radius to 0.6, but we need to make this greater than and 0 for the count, and that'll get our virus growth going. Let's try that. And we'll keep the same color scheme, in which case we had some sort of reddy pinkish thing over here, I think is what we had. Alright, and now we need to recycle this and keep the loop going, right? So we're going to do a time test, which also acts as a way to control how fast this occurs, but we're going to send them back up here now, and we'll put a pin in this, right? So we can make it look nice for a minute. And then we'll do something like 4 with a 3 variance. And now when we do our time slider, we can see that we've achieved our gradual particle virus growth over the surface of the sphere. And now it's just a matter of, changing any test conditions you want, right, and playing with the time. In the original, we had 6,000 particles, which is going to increase this dramatically because there'll be more neighbors, right? So you can see how that really affected how the growth looked and how it looks over time. So if you want to play with the time in your version, you can try and adjust this absolute distance for the surface test. That's when it first starts off. I wouldn't play with it too much because you don't want it growing up too fast, right? So that one I would keep fairly low. But the property test is what the pink particles, which is the thing that keeps this growth going. There's nothing for you to not say you couldn't do it a bit faster. So you can see it's going to happen a lot faster now when I change that to 0.8, right? And we'll put this back to 0.6. You can also see that we could adjust this a little bit by affecting this time delay. This is a time delay, right? So if we do 6 here, the growth is going to go slower over time. Now for a home project, you could do time measure on this and make these look like a growing mesh and make it look really cool if you actually textured this whole thing and everything. For now, we're just going to cheat and do the same thing that we did in the tutorial we were looking at the beginning, and we're just going to say hit the tab key and start to type shape, and we'll put the shape in here, keep it in order. Let me go down there. We'll display geometry, and we're going to make it a 3D sphere, and we're going to make it something like geosphere mid-res. We'll set the scale to maybe 80%, and we'll do a large variation, say 65, so we get a lot of different size. And let's see how that looks. And I mean, that's not bad. So you could play with lots of things, but I'm going to leave it to you at that. We could even just say try and add another 3,000 particles and see what happens. Alright, so now we've added a lot of density to it. So really, that's the beginning of a virus growth kind of particle effect. So here's a variation of the tutorial we just did. And to get this random starting pattern, I'm actually using a property test instead of a surface test, and I'm not running the box across the bottom. Now that could be a little bit more tricky because depending on the settings you have here, these 3 settings, and how many particles you have, I've upped it to 30,000 for this render. Alright, then maybe you get either all virus growth at once, or you don't get enough, or you don't get any. So doing it this way is a little bit more tricky because you've got to kind of keep playing with your settings till you get the right random start you need. But after that, it's the same flow that we did in the tutorial. Now the main difference here is, generally you don't render these events, right? You use the time measure. You can see I've got a time measure in the flow now for this final rendering, and basically I just use the tyFlow as the source, and then you play with these settings over here until you kind of get the result you want, right? And that creates that kind of growing mesh effect on the cylinder. But I've also decided that I'm going to give my particles in this virus part of the event, right, I'm going to give them a 3D shape, and I've just used chunks and I've scaled them to about 60%, and then I'm just randomly rotating them, and I'm also giving a bit of a random material. You can see here from 2 to 5, and in my material setup I've just got different shades of grey. So these are all the shades that the particle chunks can get. So now we're getting a mixture of time measure growth with kind of chunks blended in, which just, I thought, just kind of added a little bit more to the effect. But here you can see a variation of that virus growth tutorial. Have fun playing with all this stuff. See ya.